Hey, Unity developers. Welcome back to the channel. In today's video, we are diving into a crucial topic for creating scalable, maintainable, and efficient games. Design patterns. Whether you are a beginner or a seasoned developer, design patterns are powerful tools to structure your code better. By the end of this video, you'll be familiar with 7 essential design patterns that will help take your Unity game development skills to the next level. Let's get started. First up, we have the Singleton Pattern. This one's a classic. The singleton ensures a class only has one instance and provides a global point of access to it. In Unity, this is especially useful for things like GameManagers or AudioManagers, where you need a single point of control throughout the game. Here's a simple example of how you might implement a singleton pattern for a game manager. In the awake method, we check if an instance already exists. If not, we assign it, and make sure it persists across scene loads using don't destroy on load. With this setup, you never have to worry about accidentally creating multiple instances of your game manager, which can cause all sorts of headaches. Next up is the observer pattern. This pattern helps when you have a system where an object needs to notify others of state changes. For example, think about a scoreboard that updates whenever a player scores. The observer pattern allows the subject, the object being observed, to notify all the observers when something changes. In this example, we have an iObserver interface with a method on notify, which will be implemented by any class that wants to observe changes in a subject. The subject class manages a list of iObserver instances and provides methods to register or unregister observers. When something changes within the subject, the notify observers method is called, looping through each observer in the list and invoking their onNotify method. This pattern helps to decouple the objects that produce events from the ones that respond to them. It's commonly used in scenarios like event handling, user interfaces, or game state updates where multiple components need to react to changes in one central source. In Unity, this is especially useful for things like UI updates or game logic notifications, ensuring that objects can stay in sync without tight coupling. Now, let's talk about the command pattern. This one's perfect for handling complex game interactions, like undo, redo functionality or user input systems. With the command pattern, you wrap a request or action inside an object, separating the requester from the executor. For example, here we have a jump command. The player can perform a jump action, and if we want to allow for undoing that action, we can just call the undo method on the command object. This helps you keep things modular, and also adds the flexibility to change or extend your game interactions later without affecting the entire codebase. Let's move on to the strategy pattern. This pattern is all about defining a family of algorithms or behaviors and making them interchangeable. So, if you have different ways to move a character, like walking or flying, the strategy pattern lets you swap between them at runtime. In this example, the iMovement strategy interface defines a method move, which is implemented by different movement types. We have two strategies here, walk movement and fly movement, each implementing the movement logic in their own way. The character class has a reference to an iMovement strategy, which allows it to change its movement behavior at runtime. Through the setMovement strategy method, the character can switch between walking or flying. During each update call, the character delegates the movement to the current strategy by calling move. This way, the character doesn't need to know the specifics of how it moves, it simply uses the strategy. The strategy pattern is useful when you want to decouple an object from its behavior, making it more flexible and easily extensible. For example, in a game, you might want to swap between different movement types for a character based on context, without changing the character class itself. This pattern promotes clean, modular design, especially when multiple behaviors are involved. Now, let's dive into the factory pattern. This pattern is a creational pattern, which means it helps with the creation of objects. The factory pattern abstracts object creation so that subclasses can decide which specific class to instantiate. It's incredibly useful when you need to create different types of objects that share a common interface but may have different implementations. Let's say you have different types of enemies in your game, like zombies, ghosts, or skeletons. Instead of directly creating objects of these classes, you can use a factory to handle their creation. This keeps your code cleaner and more maintainable. As you can see, the enemy factory class contains a createEnemy method that instantiates different types of enemies based on the input type. This keeps the creation logic centralized and simplifies the rest of the game code. You can now spawn enemies in a clean, efficient way, and if you need to add new types of enemies in the future, you simply add them to the factory without touching the rest of the game logic. Next up is the Decorator Pattern. This pattern lets you add new functionality to objects dynamically without modifying their original structure. It's ideal for adding features like special powers or buffs to objects at runtime. In this example, we have a weapon class, which defines an abstract method getDamage. The sword class is a concrete implementation of weapon, returning a fixed damage value of 10. The key to the Decorator pattern is the Weapon Decorator class. This is an abstract class that also extends weapon, but its role is to decorate an existing weapon object. It holds a reference to a weapon and delegates the getDamage method call to it. The Fire Enchantment class is a specific decorator that extends Weapon Decorator. It overrides getDamage to add extra damage, in this case, 5, on top of the base weapon's damage. So, when you combine a sword with a fire enchantment, the damage becomes 15 instead of 10. This pattern allows for dynamic behavior modification. You can create multiple decorators, like poison enchantment, ice enchantment, etc., and combine them in different ways to build complex objects without changing the original weapon class. In Unity, the Decorator pattern is helpful for games where you want to add additional attributes or abilities to objects, like weapons, without modifying their core functionality. Last but not least, let's talk about the state pattern. This one's a game changer when you have complex state-dependent behavior, like player states or AI behaviors. In this example, we have the iState interface, which defines three key methods: enter, execute, and exit. These methods represent the life cycle of a state. Each state will implement this interface to handle its specific logic. We have two concrete states here: idle state and moving state. Each of these classes implements the iState interface with their own logic for when the state is entered, executed, or excited. The state machine class is responsible for managing and transitioning between states. It holds a reference to the current state and provides a change state method to switch between states. When changing states, the state machine calls exit on the current state, switches to the new state, and then calls enter on that new state. The update method is responsible for calling execute on the current state, making sure the correct behavior is being processed each frame. This pattern is great for scenarios where an object has multiple distinct behaviors depending on its state, like characters that can be idle, moving, attacking, etc. It helps in organizing the logic for each state separately, improving clarity and maintainability. And there you have it. 7 design patterns that will level up your Unity development. If you start using these in your projects, you'll see how they help make your code more scalable, maintainable, and easier to manage. If you found this video helpful, don't forget to like, subscribe, and hit the bell for more Unity tips and tutorials. Let me know in the comments if you've used any of these patterns in your own games, or if there's a pattern you'd like me to cover in more detail. Thanks for watching, and happy coding.